Another special type of covalent bonding is coordinate covalent bonding. A coordinate covalent bond is formed when one atom contributes both bonding electrons. An example of this would be in the bond that forms between carbon and oxygen in the compound carbon monoxide. So remember when we were doing covalent compounds, at first we were looking at how many valence electrons each atom has and how many it needs. Well, before we saw that the one that needed the most went in the middle, and what the other ones needed added up to the amount that that one that needed the most needed. So in this case, there's only two atoms. Carbon needs 4, oxygen only needs 2, so it's kind of lopsided. Well, they'll still share. So here's oxygen with its 6 valence electrons in blue. Here's carbon with its 4 valence electrons in black. And they go ahead and share 2. They can only share 2 because oxygen's full once it has 2 that it shares. So oxygen has a complete octet. 1, 2, 3, 4, 5, 6, 7, 8. Carbon, however, is stuck at 1, 2, 3, 4, 5, 6. So carbon can't be stabilized with just 6 valence electrons. Oxygen is still willing to form this bond, but what it has to do is it has to take 2 of its valence electrons that it's going to contribute as a coordinate covalent bond. So see, I've circled these 2 over here. What happens is oxygen doesn't give them to carbon because oxygen needs to keep its octet. It doesn't require one from carbon to share because then carbon would have more than 8 valence electrons. What actually happens is oxygen is going to share both of these valence electrons directly with carbon, and that's called a coordinate covalent bond. We indicate that with an arrow. It's not a dot to empty spot. Don't get it confused with ionic. But this arrow represents that it's a third bond. Here's our 1, 2 regular bonds in red, and then this blue arrow is a third bond, but it's a special kind of bond called a coordinate covalent bond. And what happened was oxygen gave both of the electrons in this bond. So again, this is called the coordinate covalent bond. Now another way that we can look at covalent compounds is sometimes a covalent compound actually has a charge to it. This is called a polyatomic ion. So you have a whole list of polyatomic ions like sulfate and sulfite and hypochlorite, chlorite, chlorate, perchlorate. So a polyatomic ion is just a covalent compound that has a charge. Covalent bonds form, but one or more elements is left without an octet, and additional electrons are needed. Each added electron contributes a negative charge. So if we add 1 electron, the charge of the polyatomic ion is -1. If we add 2 electrons, the charge of the polyatomic ion will be -2, etc. Hypochlorite is an example. Hypochlorite has the symbol ClO with a -1 charge. Again, let's look at our chart. Chlorine has 7, needs 1. Oxygen has 6, needs 2. So they can bond, chlorine with its 7, oxygen with its 6. They will share 1 because that's all chlorine can share before it gets a full octet. Now, could you consider coordinate covalent bonding for this? The answer is no. The reason being because oxygen has 1, 2, 3, 4, 5, 6, 7. It's short 1. If chlorine took these 2 electrons right here and did a coordinate covalent bond, oxygen would have 9. That's too many. So instead, what happens in this kind of bonding is oxygen receives an electron from the outside. It's just a cation that's going to donate an electron. It could be from a cation like sodium or calcium or really any metal or polyatomic cation like ammonium. We designate this as the electron being circled with a negative to show us where hypochlorite's -1 charge comes from. So basically, We've added an electron, and we've seen that hypochlorite has one bond between chlorine and oxygen. Chlorine already had a octet. Oxygen did not have a octet, so we had to add just one electron to give it the -1 charge. Now, there are other cases where we can have a coordinate covalent bond within a polyatomic ion, like chlorite. Chlorite is like hypochlorite, except for it has 2 oxygens instead of just 1. And hypochlorite and chlorite both have a -1 charge. So what happens with hypochlorite is going to be somewhat similar to one of the oxygen atoms for chlorite. Now, if you notice, I put chlorine in the middle. Whenever you have a polyatomic ion with oxygen, you're going to put the oxygens on the outside and the other atom in the middle. So one oxygen binds to the chlorine, the other one gets a coordinate covalent bond. The reason being because chlorine was full after 1, 2, 3, 4, 5, 6, 7, 8, and it couldn't bond to this oxygen unless it did it coordinate covalently. Well, oxygen has 6, and when you give it a coordinate covalent bond, here's 7, 8. Chlorine still has 1, 2, 3, 4, 5, 6, 7, 8. What about this other oxygen? 1, 2, 3, 4, 5, 6, 7. So how will it get up to 8? Do we need to do another coordinate covalent bond? No, we only do coordinate covalent bonds when the other atom needs 2 electrons. Oxygen over here only needs 1 more, so it's going to come from an outside cation. We're going to draw it like this to show that that's where the -1 charge in this polyatomic ion came from. How about chlorate? You might want to try it before you watch. Chlorine has 3 oxygens that it needs to bond to. It can bond to 1 because it can only bond 1 time. How will it attach to the others? Coordinate covalent bonding. Which one doesn't have an octet? Well, chlorine does. So it has 1, 2, 3, 4, 5, 6, 7, 8. This oxygen, 1, 2, 3, 4, 5, 6, 7, 8. This oxygen down here, 1, 2, 3, 4, 5, 6, 7, 8. And this oxygen over here, 1, 2, 3, 4, 5, 6, 7. So this one does not have a full octet yet. It can't take a coordinate covalent because that would give it 9. So again, we get a negative charge for chlorate because of that extra electron that comes in. Now try perchlorate, that's ClO4 with a -1 charge. See if you can figure out how to do it. Pause for a while. So you put the chlorine in the middle. It can only bond 1, so it bonds with this oxygen up here. Of course, when oxygen only gets 1 bond, it needs that extra electron. That's where the -1 comes from. Chlorine has 6 other valence electrons. It does a coordinate covalent bond with each of those other 3 oxygens. And that's how we do coordinate covalent bonding for polyatomic ions.